TEK 9a is in our exponential unit, and it's about exponential functions, domain, and range. It says the student is expected to determine the domain and range of exponential functions of the form f of x equal to a times b to the x power and represent domain and range using inequalities. Okay, we've done domain and range with linear equations. The information is the same, the function is different. So there's two ways we can talk about domain. It could be bounded, which are going to be some of our real-world examples, bounded maybe even on one side instead of both, or unbounded, where the question is more math-based and it extends for forever in a couple directions. Now, if we look closely here, when we're talking about the domain, we're talking about the x values where this graph shows up. So this graph shows up between 1 and 2, negative 1 and 2, which is why negative 1 and 2 are here in my domain. We're saying that the interval between negative 1 and 2, including 2, since it's a closed-in dot, which is why we have the line underneath the less than sign, is where the graph shows up, which is true. Okay, with the range, we're saying that the bottom of the graph is here at 1 with an open circle, and at the top of the graph is there at 8. We're still doing left to right for domain and bottom to top for range, just like we did with linear. Okay, in an unbounded exponential graph, we would notice, and it's not drawn on this picture, that the graph would extend forever in two directions. Now I'm saying two, and even though it's going off the page both ways, this side's going to keep going all the way up to infinity, and this side's going to flatten out, and come as close to 0 as possible. But a property of exponential functions is that they have what's called an asymptote, which means that there is a dashed line that's invisible here, that this graph is going to get close and close and close and close and close and close, close to, but never touch. We're getting into infinitesimally small numbers when we continue going out to the right. So we know that this graph extends all the way to the left and all the way to the right, which is why the domain is all real numbers, but that the range has a bounding point at 0. It won't cross that green line I've drawn on there, which is the x-axis, or y equals 0. So it's everything above it, which is why we use that greater than sign. Okay, again, we're going to look at the two types of functions here. All the time for regular math examples, we're going to have all real numbers when it's extended from one side to the other with our domain. Because from the left to the right, it's just going to keep stretching and going on forever. We can keep zooming out on a graph, and it would never stop. But the range is going to be bounded by that asymptote. So this one, since it's all below the asymptote, would be y less than 0. And this other side, since it's all above the asymptote, the line that it's never going to cross, it's y greater than 0 for the range. So the domain is pretty constant unless you have a bounded graph, and the range will depend on if the graph appears above the x-axis or below the x-axis. We have a couple things on our formula chart for domain and range that still can help us. Dolor the robot is going to help us remember that domain is from the left to the right, and robot is from the bottom to the top. That's how we describe the graph. And Dr. XY helps us remember just first of all that domain is x and range is y. Helps us eliminate answer choices because sometimes they're going to ask you for domain and give you a range with a y variable. We don't want that. So for example, it says, what appears to be the domain of the part of the exponential function graph in the grid? So it's exponential, but it has boundaries. So I'm going to use the same sort of idea from linear to tell me the domain and range. Oh, that's a lie. I'm just finding the domain. If I think back to Dr. XY, the domain is the x's, which means any answer choice with a y in it doesn't answer my question. Just from knowing what the domain is talking about, I thought it could be 50 shot of getting this right. Now if I actually go look at the x values, this graph appears on the x-axis from 1 to 3. This is the interval where everything exists for that graph, between negative 1 and 3. This one says the graph of an exponential function is shown on the grid. This one doesn't have endpoints. It says based on the graph, which statement about the function is true. Okay, and then it gives us some in words. We can translate these to math. It says the range is the set of all real numbers less than 0. So range is less than 0. Does it all appear down here less than 0? No, that's not true. So we're not going to choose that one. Next one says the domain is the set of all real numbers greater than negative 4. Okay, well, here's where x is greater than -4, but don't I know that this is going to keep extending out if I zoomed out? That would be not true. Range is the set of all numbers greater than 0, so y greater than 0. Does my entire graph appear above 0? That looks good. We'll hang on to that one. And D says the domain is the set of all real numbers less than -4. Again, here's -4 on the x-axis, and it would be saying that it all appears over here. That's not true in the slightest. So we would choose answer choice C, that the range is greater than 0. We empower, we impact, we love. We are Skeeter Nation.